Hi everyone, my name is Ayonnah Tinsley and I'm a program assistant here at Rosie Innovator, and I'm also the teen author of my very own STEM children's book, This Is What Engineer Looks Like. And welcome back to another Snack Time Science, where we're going to be talking about the periodic table today. Okay, so in general, chemistry is such an interesting topic because it can range from kind of figuring out what makeup products we can use that's safe for us, for figuring out what can go inside of this awesome candles for it to be able to melt, and lastly, what kind of fibers and polyesters have to go together to make the squishmallow so squishy. So chemistry is essentially the basis of how things work and what is safe for us, what's nutritious for us, etc. And today we're going to be talking about the basis of it all, kind of foundation, the periodic table, which is a whole table display of elements. And an element is something that cannot be decomposed to a simpler substance. We'll go more into that later. And also the periodic table is really interesting because it organizes all these elements in a variety of ways and not just by their atomic number. Okay, so we know that the key term here is element. So essentially what an element is, it can be a liquid, a gas, or a solid, and it's something that cannot be decomposed to another more simple version of itself through a natural chemical process. So you can think of this how like in Kool-Aid, we know it's a physical change, mixing the powder together with the water, because we can boil it back down and separate that water from the powdered sugar again. Or even in water, more of like a chemical change, the hydrogen and oxygen molecules combine to make H2O. But then when we separate that up again, and if we want to separate hydrogen and oxygen, that's not exactly possible. We can't get really any simpler because hydrogen and oxygen are both elements, a part of the periodic table, and we'll have to look a little deeper into their protons and electrons to figure out what those are made of. And then fun fact, pretty much with protons, every single element on the periodic table will have a different number of protons, and this is kind of like their little identification for which element is which, because no two elements will have the same amount of protons, but when it comes to electrons and neutrons, it's a different story. Now, speaking of stories, now let's go into the actual story or just history of the periodic table. So it kind of all started with Dmitry Mendeleev of Russia. So before Mendeleev's time, actually, and scientists before him, elements were discovered. Like the concept of an element, it was known, but he was the one that really put together the idea of putting all these elements on a table. He knew that there wasn't an infinite amount of elements. It's kind of a set of elements that are on Earth, and he actually was able to predict the amount of protons that would be in these elements by figuring out that kind of pattern with atomic number correlates to how many protons would be in an element. And he even drew up a table and had these empty spaces because he was able to predict, he was able to find these different patterns and predict what was going to happen, and he was just all ready and awaiting for the other elements that would be discovered in the future. Then, of course, in the later half of the 1800s, we know Mary Curie, she discovered two more elements, which were radium and polonium, and these were very important elements towards the periodic table. And then some even later developments of important developments of the periodic table were in the early 1900s, where Chadwick and Rutherford, they were each responsible of discovering a new part of the periodic table or essential part. So Rutherford, he actually discovered that protons were inside the nucleus instead of outside where the electrons are. And Chadwick, he discovered that neutrons in general existed, and then this later led to isotopes being known, but that's for a whole different lesson. Okay, so now we're going to actually talk about what the periodic table actually tells us about an element. So first, let's start off with helium. Yes, the same helium that makes balloons float all the way up to the sky. So pretty much with helium first, we can see that on the periodic table, it belongs to the group called noble gases. So groups are categorized vertically on the periodic table, while periods are categorized horizontally, and we'll get more into what exactly this means. Now let's see what the kind of squares that you see on the periodic table actually tells us. So it's going to give us three really important basic information. It's going to give us the rounded atomic mass, that's why it's a whole number at the bottom, the atomic number, and the actual atomic symbol. And in this case, helium, it's going to be just He, but sometimes for other elements like gold, silver, it'll actually be Ag or Au, which is completely different. So that's pretty interesting history on why that is. So pretty much now, so we know those numbers, but now let's figure out how many protons, electrons, and neutrons are inside of an atom of helium. a sensitive element. So then we're gonna find that here. And then for the protons, we're gonna use the atomic number. So it's gonna be the same number of protons as the atomic number. And the same thing goes for the electrons. So in any element on the periodic table that we see here, protons and electrons will have the same number. But for the neutrons, that's where it kind of gets different. But all we're gonna do is subtract the atomic mass minus the atomic number to get the amount of neutrons we can see in helium. In a lot of cases, it's the same number as the amount of protons and electrons that we found earlier. So it's really interesting getting to see how all these numbers are the same, and it's a super satisfying math problem. Okay, so now the last part of this little video here, Snack Time Science, we're gonna be focusing on a little bit more vocab and a little bit more about periods and groups. So essentially, first thing I wanna talk about is how in groups, so like I said before, the kind of vertical organization where alkali metals and everything are, so pretty much groups, that vertical organization, all of these in each group, they will all like react similarly. Like noble gases, they're not very reactive, while group 1 is super reactive, and it's all due to the number of valence electrons. And what valence electrons are, so like our orbitals with our rings, the outer ring is called, and the electrons in the outer ring of these atoms, of these elements, are called our valence electrons. And of course, our orbital rings are the rings kind of outside the nucleus, where kind of like the Rutherford model, the scientist I mentioned earlier, these rings is kind of like part of his theory of where the electrons kind of sit, and it's just a really nice way to organize it. So we just call them shells or orbitals, like you'll see in your little battleship game. So two vocab words down. And then also, so now we're gonna go into actual periods. So periods is the horizontal organization of the elements. And this means like the amount of orbitals. So like period 1 would have the same amount of orbitals, and then as you go down, it's the same thing as that. So essentially groups are kind of more about reaction. Valence electrons kind of influence how reactive an element is, while periods just focus on like how many rings of electrons they will have like around their nucleus. Okay, so that is all the chemistry wisdom I had to share for you today. And please remember, I hope that you were able to grasp these concepts, rewatch the video if you need to review anything else. And also remember that chemistry is pretty much a part of everything, whether it's through paintings you might make in art class, or even in the technology we use every day. So you're definitely using an element on the periodic table every single day. So I hope you find that super interesting. And I'll see you next time on Snack Time Science. And don't forget, we can do it.